I am super excited that you guys are watching this video. I hope you find this helpful, and yeah, let's just get on straight into it. So, you have to find the characteristic polynomial of this matrix, okay? So, first things first, what you would have to do is you would have to know this formula. Let me put this in a different color so you guys can see. Or better, yeah. You have to use this formula. And I forgot to say here that A equals this, right? So lambda is honestly is a scalar multiple of the identity matrix. And if you don't know what the identity matrix is, it's basically for this 3x3 matrix, but it's based on like the size, honestly, of what A is. So for this 3x3, it would just have a leading term of 1, 0, 0, and then to the right of it, it would have that. But that is the identity matrix. This is the identity matrix, IN. But with the identity matrix, you're multiplying what lambda is, which is this this symbol. You're multiplying the identity matrix by lambda. But if you have nothing to multiply lambda by, if there's nothing saying that lambda is equal to this number, then you would just have to replace all these ones with lambdas. So then you replace lambda here, and lambda here. But mind you, this is for a 3x3 matrix, okay? But as you can see, it's always going to be on the main diagonal, okay? Just so you know. And this is the main diagonal, if you guys don't know what I'm talking about. This is the main diagonal right here. That's what I'm talking about. And this is the secondary. I shouldn't have put it in the same color. I don't know why I did that. But that's the main diagonal. And I'm gonna just maybe leave this up here in case it helps you. But, yeah, so let me just put this in a color. Let's do purple. So, knowing this and knowing that we have this formula and knowing we have our A, we know what the identity matrix is. We don't have a lambda equals 2. And so if it doesn't have an equal to, then it's just going to be lambda across the main diagonal. You can honestly skip this step and then just subtract lambda from the main diagonal of the actual matrix. But for the purposes of this video, I would just do it all out. If you don't feel like comfortable yet doing it, that's perfectly fine. Honestly, I'm not gonna, I don't judge. 0, 1. So -4, 3, right? And -4, yeah. You have to make sure that you copy down everything correctly, because it's just like one little negative, one little thing that's off, and then your whole matrix is off. You can get the correct process, but you solved for that matrix. That's not the original matrix, so keep that in mind. So then we have our A here. Let me just label this as our A minus minus this, which was explained earlier. I don't know. I guess I'll put this in a different color. Why not? Just for you guys to know that it is different. So, like I said again, this is it's the same color. Like I said, this is across the main diagonal. Everything else is going to be 0. Oh. So after you do that, then you are just going to subtract it as normal component wise. So what you would do here is you would take, if you don't know kind of what I'm talking about, you would take the first item or the first element or whatnot, and then you would subtract it by this first element. And then, oh my gosh, I'm so sorry. This was a negative one. This is actually a positive one. You see, I looked back at the notes. Good thing I looked back at the notes. Let me just make sure so we don't get this wrong, okay? But yeah. So that's kind of the way you do it, and then you would just do it all across there, right? So I like to do it in color so you guys would see the action going on. Okay, so then you have this matrix. So 1 minus lambda is just 1 minus lambda. 0 minus 0, 0. 1 minus 0, 1. Minus 4 minus 0, that's just minus 4. 3 minus lambda is 3 minus lambda. And then that would be negative 3. 0, that's 0, 7. And then 0 minus lambda is minus negative lambda, minus lambda, same thing. And so, boom. Now we have everything where it needs to be. And then we can go on to the next portion of the problem. So, what you can do, I've seen this in other ways as well. But what you can do is that you can do cofactor expansion, right? The reason why I'm saying that you can do cofactor expansion, I personally kind of like doing cofactor expansion, is it is just a lot of bookkeeping that you will have to do. I really do feel like that comes with practice. So take with this what you will. But what you can do, let me see if I can get a lighter color. I say cofactor expansion because we do have a 0 here, and then we do have a 0 here, but usually, ideally, everybody goes by the first row, so here. But the thing is, if this was 0 and this was 0, then you would go by the first column. But I think, everybody goes by the first row, in my eyes. So here's what else I would also like to say is that for cofactor expansion, if you have a hard time understanding of the alternating signs, for a 3x3 matrix, this has been made so much more simpler, and I'm going to show you how. So, for a 3x3 matrix, this is how it's set up, in a way. And then this is plus. Yep. So, you can remember this, but what I would want you to remember is this important part. You have learned this since elementary school. Never eat soggy waffles. Never eat soggy waffles. And once you identify this with a 3x3 matrix, it becomes very simpler on the things that you would have to alternate or things that you would just have to stay the same. You would still, if you're doing this online and the teachers maybe not take, I don't know. Do with this what you will. But it goes along with the summation of -1 to the ith plus jth. The ith row plus jth column. and then with a number, and then the determinant of deleting that row and column, right? But if you just kind of want to know ahead of time and know that you're right on alternating these signs, I would recommend doing this. But also, what you can do as well, what I always do, is I always put it on the top, put it on the side, put it on the bottom. I go in that row. So then I know anything that's over here, anything that I did not mark, that's a positive. That's going to have a positive alternating sign to it. That's how I understand it by. Take with this what you will. Okay? But I'm going to just leave that up there. Okay? So now that we have that, and now we are understanding, okay, we're doing this by the first row. What we're going to do is set up the cofactor expansion. Yay. So, with cofactor expansion, for this one in particular, we can do A, and this is going to be row 1, column 1. So, row 1, column 1, column 2, column 3, right? Just to make sure, just to make sure you guys understand. So row 1, column 1 is row 1, column 1 times row 1, column 1. So that's what you're going to do. But do you see here? This is why I said that it's important to understand the alternating signs. Because you see here, we have a minus there. So it's going to be minus A12, C12. Plus here, A13 times C13. A is the first, like the element that you are selecting, and then C is the row and column that you are deleting by. If that makes sense, hopefully. So let me just go back to my colors. I like doing things in colors. So we could just, now all we have to really do is just plug this in. We know that we're going by row 1, column 1. That's what we know, right? So I'm gonna just bring this over here so we can have more room. So what you would do, you can set it up like this if you really wanted to, like that. But it's that just means this. All this really means that it's just going to be alternating. We already know that's a positive from here. But you can't put it, honestly. I mean, if that's what your professor, that's what your teacher allows, do what the professor says, right? 1 minus lambda times the determinant of, so now this is C row 1, column 1, right? So row 1, column 1, we're deleting that. And so let's see, what do we have left? Okay, we have 3 minus lambda, minus 3, 7, and then minus lambda. So then we're just going to write that down. So 3 minus lambda, minus 3, and 7 minus lambda. Boom. Let me just scoot this over here. Okay. So then after that, you're going to do that for 0 and 1. The easy part about 0 is that everything times 0 is 0, so you don't really have to do that. What I like to do is I like to put minus because it's at north. And I'll put 0. And then now all we have is plus here, so then we're going to put plus. Or you can just put the ith and jth column of that, which will still equal a plus. But like I said, talk to your professor about it and see what he says. Okay, so now we're at 1. So now we have to delete column 3 because that's where 1 is at. And so what do we have left? -4 determinant of -4, 3 minus lambda, I think 0 and 7. Yeah. Right? Yeah. So now we have that. I like to personally split this into problems so I don't confuse myself, because you can get confused very fast if you are not careful about what you are doing. So first things first, what I do is A, B, C, and D. And this gives you the determinant of the matrix, right? Of this 2 by 2 matrix, because once it reduced to 2 by 2, then you are able to use the A times D minus B times C, right? So A times D. So then you would just do A times D, or you don't even have to remember the A times B minus C times D. If that's what your professor allows, whatever. But what I always do, I always know that I'm going to be multiplying this, and I'm going to be multiplying that. And then subtracting. That's literally what I do. But for the purposes of this video, I would like to show you. And so then you write it like that. And so then, mind you, just because that this is a -3, that does not mean you don't put the minus there. You have to put the minus there. You have to. It's a part of the formula. So this is A times D minus B times C. So then after that, what you can do, you could just simplify like normal. So then this will be -28 minus, well, this will just be a plus, wouldn't it? And then minus lambda, and then 3 minus lambda. So then after that, personally for me, I factor this out. So minus lambda times minus lambda, when you're timesing, you're adding the powers. So this would just be, and then also -1 times -1, that's just 1. Because they have a -1 coefficient right here. So then it would just be positive lambda squared. And then you're going to do the same thing here. So 3 times minus lambda. That's just 3 times minus lambda. And then that plus 20 on the side. Boom. We're done getting the determinant. That is the determinant, okay? So then after that, we're going to focus on this side of the problem. This side is pretty simple. But I said 28. I'm sorry. This is supposed to be 21. I'm so sorry. But essentially, you're doing the same thing. So you're just doing this, or the A times B minus C times D. And then you're just doing -4 and 7 minus, 3 minus lambda times 0. This would just go to 0, and then you would just have -28 here. So then after that, you're like, okay, what do I do? And this is why I said that you need to make sure that you are bookkeeping like crazy, or keeping everything in mind, okay? So here's the thing. So now you found the determinant. Now you have to go back up and you have to figure out what is this determinant being multiplied by. Because see over here how this is A11 times C11, and then minus, this is in the same format that we have. This is the 1, 2 times C1, 2, but this just goes to 0, so we didn't have to do anything for that. And then plus A1, 3 times C1, 3. This is in the same exact format. And here is the thing. We didn't solve the problem by just doing this. We just got the determinant. We just made it simpler for ourselves to solve the problem. We didn't actually solve it. No, you have to multiply it by the ith and jth column at that specific element that is being multiplied by. So, is that my purple? I don't know. My purple was nice. Oh, yeah. So then you have 1 minus lambda. And then you have 1 minus lambda over here. So you're just going to bring this down. And then, actually, I'm going to move that. I feel like this is a little too congested. That's fine. I'll just delete the 2. Right here. Yeah. So then after that, this is just negative 28 times 1, which is just negative 28. So then you're going to put the negative 28 outside of here, right? So now, just make sure that now with this next step that you're very careful about the subtraction, the adding part of it, because it can get a little tricky. Do not get me wrong, it can be a little tricky, but you can sure handle this. So, next, you're just going to simplify. Where you're just going to where you're gonna FOIL it out, like this. Oh my gosh, sorry, distributive property. So we have negative lambda times lambda square. Remember I said multiply, you're adding. That's with everything. With anything. Not even with lambda. It could be x squared times x to 1. That's x3. Okay? So minus lambda to the 3rd power. And then minus lambda times minus 3. So this is saying minus 1 times minus 3. That's just 3. Okay? So add 3 lambda squared, because they both have 1 power to them. And then after that, you're going to do minus lambda times 21. So then that would just be, yeah, that would just be 21 lambda. Okay? And then after that, what you're going to do, what I like to do, is I like to draw a line. Now, you can erase this line during the test or whatever during your test, because it's not really, this is just for separation purposes, so you don't get confused and start writing stuff twice. This just lets me know that I am done with this part. This lets me know I'm done with multiplying lambda by all of this. Okay, now we're going to go on to this part. That's really it. That's really all I do. But like I said, it can be very tricky, and it's just honestly, linear algebra is you're really doing a lot, with row reduction and all that stuff. So it just gives me some peace of mind that I can separate my work, and I'm like, okay, that makes sense. That's literally all it does for me. But so what you're gonna do, since it's being 1 times everything in here, 1 times itself is itself. 1 times 1 is 1. 1 times 2 is 2. So if 1 times this quadratic, this polynomial, sorry, 1 times that's itself. So that's what you're going to do. So you're going to do plus lambda squared minus 3 lambda plus 21. And then you're going to add that little line like I told you to. And then after that, you're just going, oh no, not yellow, sorry. You guys probably can't see that. then minus 28 because of the 28 here. It's just gonna go on the end. That's really it. But yeah. But here's the thing, like if this was a 2, then you would have to, multiply this times 2, so you would basically double it. But yeah, I mean, it goes along with the same logic. But nevertheless, so what do we have here? We have this big chunk. How can we reduce this to make sure that this is accurate as possible? Combining like terms. Yes, combining like terms. So with combining like terms, I always just kind of like to scan and do the easiest ones possible first. So I already know it's 21 minus 20 minus the negative 28. That's what I always like to do. I think it's very simple. And then I just kind of gradually keep on getting it larger and larger. So then this is 21 minus 28, which is, minus 7. So minus 7 will go here. Boom, we're done with that. I like to cross it out too, so you don't start adding stuff and subtracting this, that, and the third. So then, okay, now we're gonna let's go with the regular lambda. So we have minus 21 lambda, and then minus 3 lambda. So this is saying minus 21 minus 3. And then you would just put the lambda that is right beside it. Sorry about that. So yeah, you're going to get minus 24 and then minus lambda. So then, like I said, cross that out. We're done, right? So then we have minus 3 lambda, positive 3 lambda square plus positive lambda square. So this is saying 3 plus 1 because of the coefficient right here. That's 1. So 4 lambda square and then minus lambda right? So then yeah, this becomes your polynomial, and you're gonna put all of this together. So you're just gonna put all this together. Minus lambda third plus 4 minus lambda square minus 24 lambda minus 7. And that is going to be your characteristic polynomial. I hope that this was very helpful. I hope you found some information. And I hope that the little tips and the little tricks that I set out for you guys is very helpful. Please make sure, like, if you ever going to use these little tips or tricks, like dividing the parts and stuff like that, just to make sure that you have 3 sections, please understand that maybe your teacher would not allow it, or take points off, your professor or whomever. Use this as a kind of a guide, but I don't know how your professor likes to do it. So maybe jot this down and ask them if this is okay. So you can be better equipped, because I don't want you to get the points off or the points wrong because you kind of did a bookkeeping trick that wasn't taught to you. So yeah, take this what you will, and yeah, leave a comment down below on how I did, and also how I did communicating. Did you guys understand me well? And yeah.